Okay, for the second part of 3.2, we're going to talk about complex numbers. Okay, now we've talked about imaginary, and now we're going to talk about what this complex number business is. Okay, and that is when, written in standard form, you have a plus bi, which means you have a number a plus I, and it may or may not have a number in front of it. Okay, a is the real part, it's the real number, and the bi is the imaginary part. Okay, so if we look over here at this chart, it talks about complex numbers here. If you have 0i, that's where you get the real numbers. Okay, those can all be plotted on a number line. When b is not 0, you get imaginary numbers, and they are always written in the form a equals, not a equals, sorry, a plus bi. Now, if b is negative, you would just change that to a minus, but the real number comes in front of the imaginary number, okay? So let's try that here. We're going to use that with our equality of two complex numbers. We want to find the value of x and y that satisfies the equation. So we're saying this is a, and this is bi. And this is a, and this is bi, and they equal each other. Well, for that to be the case, a has to equal a, so 2x has to equal 10. And bi has to equal bi, so negative 7i has to equal yi. So we can go ahead and solve these two things. Let's solve 2x equals 10 first. We're going to divide by 2. So I have that x is 5. And then if we solve for the y, if I divide both sides by I, they both cancel out, and I'm left with y is negative 7. Okay, so let's go to number 5. So here's a, and that's a. So I know that 5x has to equal 35. If I divide by 5, I get x is 7. And this is the imaginary. This is the imaginary. Look, if I just eliminate the i's, it's a lot faster to solve for y. Y is just going to equal to negative 20. It's what's in front of I. Alright, so go to your practice and do problems number 13, 14, 15, and 16, and then move on to the next lesson video.